Hi guys, Captain Jamie Schaefer here at MTC Maritime Training Center here in beautiful Tampa, Florida. So one of the most common questions for mariners that are either looking to get their captain's license or upgrade their captain's license, is there an easier way to figure out tides and tidal current problems? Well, the answer is yes, if you do have that tide and tidal current form. Now, I can't speak for other schools and if they use this form or not, but here at MTC Maritime Training Center, we actually give you these forms for your exam. So this video will be on solving tide problems. If you want to see more how-to videos, click that subscribe button to subscribe to our channel. And if you want to get notified when new content comes out, go ahead and hit that bell button as well. If you are going to be doing any kind of studying for either your 100-ton, your 200-ton, all the way up to 1,600-ton, even unlimited, if you are going to be doing any studying, you should get the reprints from the 1983 tide tables and tidal current tables. I got mine at Amazon, and I have a link below. Also, we have a link for all the things you see here, which is the question itself, the tidal form, and just little excerpts from the tide tables from that 1983 tidal book. So I do have a link below. You can follow along that way as well. So the first thing we're going to look at here is the tidal question. So here's the question. It says, on August 10th of 1983, you will dock near Days Point, Weehawken on the Hudson River at 1800 DST ZD plus 4. DST stands for Daylight Savings Time. Very important in this question. And then your zone description is plus 4. So it says the charted depth alongside the pier is going to be 24 feet. What will be the depth of water when you dock at 1800? So here we have the tide form, and we'll get to this in a minute. And we have all the things we need that I took out of the tide tables. Okay, so we have the tide form here. Now we have some things we can plug in already. We have Days Point, Weehawken. Your desired time is 1800 DST with a zone description of plus 4. And the date is 10 August of 1983. Okay, so we have those plugged in here. Now we need to look up Days Point, Weehawken. So if you go to your tide table and look for the index to stations in 1983, this one just so happens to be on page 285, you will see down at the bottom here, Weehawken, New Jersey, with an index number of 1521. I do want to plug that number in somewhere, okay? So we're going to come back to this tide form, and I'm actually just going to plug it in here, right? 1521. Okay. So now that we have that index number, we can go to the second thing, which is the table 2. Okay, that's the tidal differences in other constants. 1983. This one just so happens to be on page 213. So if we go down here and we look for that index number, right here is 1521, Weehawken, Days Point, New Jersey. And then we have some things that we need to plug in somewhere. Okay. So the first thing is the position, lat and long. We really don't have to worry about this too much on the tide table. But we do have to worry about the time differences and the differences in height. And this is both time differences for high water and low water, and the height for high water and low water. So these are the things that you really want to plug in. So at Weehawken, Days Point, New Jersey, you have on your high water time, you have 0 hours and 24 minutes. That's plus 0 hours and 24 minutes. And then on low water, you have 0 hours and 23 minutes. We need to plug those two things in. Okay, so here is 0 hours and 24 minutes for the high water time difference. And then this one is going to be 0 hours and 23 minutes for the low water time difference. We also have the reference station that we need to get out of here. So the reference station is always going to be above your index number. So this reference station is actually New York, and it's on page 56. So we need to plug that into our tide table form. So the reference is going to be New York, and it's going to start on page 56. And then we come back here and we look at the differences in height for high water and for low water. Okay, so we come back down and we look. Our high water is negative 0.3, and our low water did not change. It's 0.0. So we need to plug those into our tide forms. So this one is a negative 0.3, and this one is no change, 0.0. Okay, so now we have all this filled out up here. Now we're going to go down to the reference station and fill that stuff out too. So we got all the information that we need out of this table 2. So now we're going to go to our reference station, which is New York. It starts on page 56, but if you look, 56 starts with January, February, so on and so forth, and you get to page 58, it has August. So we want to look for August 10th of 1983, and here is some times and some heights. Okay, now this one on the right hand side, don't worry about that. That's in meters. We don't deal with meters in America. So the only two things that you really want to take away from this is the time difference and the heights right here in the middle. Okay, so let's go back to our tide form and look. So our first one, is that a high water or a low water? So the height is negative 0.9. I would call that a low water, right? So we're going to start with low water. That's a low water. And then the time is going to be 0322. And the height is negative 0.9. Okay. Come back down here and we look for high water now. And the time is 0931, and the height is 5.3 feet. Same thing here, low water now, right? Low water. And the time difference is 1536. And that has a height of negative 0.5. And our last one, high water, is at 2130. And our height is at 5.9 feet. Okay, so now we have the reference stations. Now we need to actually transfer from reference station to our locality. Well, how do we do this? This is where a lot of mariners kind of get messed up. So right here you see we have a daylight savings time anytime. It says DST, you will add 1 hour to this time. No matter what, you're going to add 1 hour to this time. So we're just going to start transferring some things. So this one's low water. So the time is going to be, we're going to add an hour to 0322 to make it 0422. And then we want to add what? So at low water, the time difference is 23 minutes, right? So we want to add 23 minutes to that. And that's going to give us a time of 0445. Okay, that's our time difference now. And our height, so if we look at the height up here, the difference in height in low water is nothing. So that's all we have to do is transfer that negative 0.9 over. So we want to transfer negative 0.9 over. Okay, does everybody understand so far? So the next one's high water. We're going to add 1 hour to 9:31 to make it 10:31. Then we're going to add, what? Is it 23 minutes or 24 minutes? We're dealing with high water now, right? So 24 minutes. And what does that come out to? 10:55. Okay. So now we have a height difference. So we have a 5.3 over here, but this is high water. We have to take away 0.3. It's negative 0.3. If it was positive, we would add to that 5.3, but it is a negative here. So we're going to subtract, which would make it 5.0. Okay. Now we're going back to low water. So the low water is 1 hour from 15:36 is 16:36. And you want to add 23 minutes, right? Because it's low water. And that gives you a time of 16:59. And then again, it is low water and there is no difference in height for low water. So we're just going to transfer that negative 0.5 over. Then we come back to high water. Okay, and our high water is 21:30 plus 1 hour makes it 22:30, and we're going to add 24 minutes to make it 23:14. And then again, we're dealing with high water again, so that 5.9, we're going to have to take away 0.3 of that to make it 5.6. Okay, does everybody understand that? Now, if it just said Eastern Standard Time, you would not add the hour or anything like that over here. You would not have any of these over here. You would just add the minutes or the hours and minutes. If it does have 1 hour and 24 minutes or 1 hour and 23 minutes, you would add those over here. But anytime it says daylight savings time, you need to add that hour and then do your high water and low water time differences. Okay, so now we're going to deal with table 3. So if you look up here, 1800 is our desired time. 1800 falls between this low water and this high water. Okay, so it's between 16:59 and 23:14. Okay, please remember that. So our desired time is 1800. So the duration of the rise and fall. So what does that mean? Well, that is if you subtract 23:14 from 16:59 in time, you'll get 6 hours and 15 minutes. Okay, 6 hours and 15 minutes. So you do that by subtracting the 23:14 by 16:59. Okay, and then your range of tide. Now, that's what this is dealing with. Now, guys, if you're using a calculator or something, I don't want you to put that negative in there and put negative 0.5 plus 5.6. Don't do the negative because it's wanting the whole range of the tide. So when it was below at 0.5 to when it was above at 5.6, that is the whole range of tide. So you need to add those, okay? 5.6 plus 0.5, which would be 6.1. Okay. So now we go down to the desired time. Is it closer to high water or low water? Well, if we look up here, 1800 is a lot closer to 1659 than it is 2314. So we're going to go ahead and check low water. Now we're going to have to do some more math. Time from the desired time to the nearest high or low water. Again, we're dealing with low water because we're dealing with that 1659. So what that means is you take your 1800, your desired time, and you subtract 1659 from it, and that's where this gets plugged in. So that is 1 hour and 1 minute. Okay? So now we have to do a correction to height from table 3. So this is where a lot of mariners kind of get messed up as well. So if you look at table 3 on page 239 of the book, you will see the duration of rise or fall on the left-hand side of table 3 and the time from the nearest high water or low water on top. And then down below you will see the range of tide and the correction to height. So this is how we do this. The duration of rise and fall. Well, let's look at our tide form. The duration of rise and fall is 6 hours and 15 minutes. Okay? So getting back to table 3, 6 hours and 15 minutes is closest to 6 hours and 20 minutes right here. Okay? Now it wants the time from the nearest high or low water. We come down, time from the desired time from nearest high or low water. That's 1 hour and 1 minute. So we're in this column here where it says 6 hours and 20 minutes, and we want to move over until we get to this right here. That's 1 hour and 3 minutes. Well, our 1 hour and 1 minute is awfully close to 1 hour and 3 minutes. So this column is the column that we're going to be working in. So once you get that, then you take that column and you come down to this correction to height. Now it wants to know what is the range of the tide. What was the range of our tide? It was 6 feet 1 inch, or 6.1, right? So we come over here to that same one in that same column and we see 0.4. That is the one we need to plug into our tide form right here where it says 0.4. Okay, that's where you need to plug that in. So 0.4 is our correction to height from table 3. Now we come down here and we're almost done, guys. We come down here to the height of tide. Is it nearest high or low water? Again, we dealt with low water today. What is it? It is negative 0.5 feet. So we plug that in, negative 0.5. And what is the correction from table 3? Well, we get that at 0.4. So the height at the desired time. So this is where that calculator will actually come in. So negative 0.5 plus 0.4 equals negative 0.1 feet. Okay, so there's your answer. So if we look back at the question, guys, it says, on August 10th, 1983, you will dock near Days Point, Weehawken on the Hudson River. At 1800 DST, zone description is 4. The charted depth alongside the pier is 24 feet. What will be the depth of water when you dock? The answer, B, right? We take that 0.1, that negative 0.1, and we subtract it from that 24 feet. Right there's your answer, 23.9 feet. All right, guys, I hope you enjoyed this video.
We'll be doing one again real soon. Thanks again.
Thanks for watching our video today on tie problems. If you want to know more information about some how-to videos that we're going to be doing, go ahead and hit that subscribe button and that bell button as well. Guys, thanks for watching. Stay safe out there.